Okay guys, so this is going to be a review over improper integrals, integration by parts, partial fractions, and Euler's method and logistical growth. Okay, so improper integrals, remember we tell if they're convergent or divergent, but they're improper because they have a limit at infinity or they have a discontinuity. So in the first example, we have a discontinuity at x is equal to 0 because we have division by 0 right here. So the way we do this problem is we say the limit as t goes to 0 from the positive side of t to 1 over dx over square root of x, like that. Okay, so we write it from the positive side because the positive side's in between 0 and 1. Okay? So we integrate this. The integral of this, so that's x to the negative 1/2. So we integrate that, we get x to the 1/2 times 2. And we're going to evaluate it from 1 to t, like that. We're going to plug in the 1. Okay, so 1 to the 1/2 is 1 times 2 is 2. Now, your t is going to 0. Okay, so 0 from the positive side is going to be 0. So this is going to be convergent. And it's going to converge to 2. Okay, the next example. Limit as t goes to infinity. Integral from 0 to t of x e to the negative x squared dx. So we're going to have a u sub here. Your u is going to be negative x squared. Your du is going to be negative 2x dx. We don't have the negative 2, so we got to get rid of it. Okay, so we integrate this, it becomes negative 1/2 e. So negative 1/2 e to the negative x squared, and we're going to plug in our t and our 0. Okay, remember, e to the negative infinity power goes to 0. And e to the 0 is 1. So this is 1/2, and it's convergent. Okay, so reminder. E to the negative infinity is equal to 0 because it would be bottom heavy. Anything to the negative power, you would drop down to the bottom. Okay, next one. Let's do the limit as t goes to infinity. Integral from 1 to t of x dx over 1 plus x squared. Okay, so this is going to be u substitution. So your u is 1 plus x squared. Your du is 2x dx. We don't have the 2, so we get rid of it. So 1/2 du is equal to x dx. So this will integrate to a natural log because you got du over u. So it's 1/2 natural log, absolute value 1 plus x squared. And we're going from 1 to t. So 1/2 natural log of 1 plus t squared minus 1/2 natural log of 2. Now, we're taking our limit as t goes to infinity. Okay, so it's going to plug in infinity. Natural log of infinity is divergent. Okay. So remember, it's convergent if you get an answer, it's divergent if you don't get an answer. Okay, so integration by parts. Okay, so our formula for integration by parts was the integral of u dv is equal to uv minus the integral of v du. And we followed laity for choosing our u. Okay, this stood for logs, inverse trig, algebraic terms, trig, and exponentials. Okay, and algebraic was like x or x squared. Okay, so we're going to integrate these two things by parts. So your u in this case is going to be x, your du is going to be dx. And I know we're going to integrate by parts whenever you don't have a u sub. Okay, and there's multiplication of two different functions. Okay, so what's left over after you choose your u is going to be your dv. And we're going to integrate this. The integral of cosine gives you a sine. Did our u sub. Okay. And then when we go to plug into the formula, it's u times v. So it's 1/2 x sine of 2x minus 1/2 the integral of sine of 2x dx. Okay. So the integral of sine is going to be cosine, negative cosine. Okay, so get 1/2 sine of 2x. Okay, so your u right here is 2x, your du is 2dx. If you don't do this mentally, we don't have the 2, so we got to get rid of it, so it's 1/2. So this becomes 1/4 cosine of 2x plus c. Okay, so a negative times the negative cosine that you would get here gives you the positive. Okay, next one you're probably gonna need a little bit of room. Okay, so anytime we do an e times a sine or a cosine, it's gonna be an iterative integral. Okay, so what we're gonna do is we're gonna identify our u. Okay, so we're going to do our trig first. So we're going to have to do this multiple times. Okay, so your dv is going to be e4 theta d theta, and when we integrate that, we get 1/4 e to the 4 theta like that. So we're going to follow the formula u times v. So u times v, so it's going to be 1/4 e to the 4 theta sine of 2 theta, okay, minus v du. So it's 2 times 1/4 is 1/2. The integral of e to the 4 theta cosine of 2 theta d theta. And we're going to repeat the process. Okay, so your u is going to be cosine of 2 theta. Your du is going to be -2 sine of 2 theta. Your v and dv. So your dv is going to be e to the 4 theta. And your v, you're going to integrate as 1/4 e to the 4 theta. Okay, so we're going to follow the formula. So we're going to follow the formula again. So it's going to be 1/4 e to the 4 theta sine of 2 theta. And then we're going to do this times this. So it's plus 1/4 e to the 4 theta sine of 2 theta. And then, wait, 1/4, sorry. Got to multiply everything by 1/2. Sorry, I'm running out of room. Let me get another sheet of paper real quick. Never mind. So 1/2. So u times v. U times v is going to be 1/4 e to the 4 theta cosine of 2 theta minus. Okay, so 1/4 times 2 is 1/2. So it's going to be a minus, a negative, so it's going to be a plus. Yeah, it's going to be let's leave it as a plus. Yeah, it's going to be a plus 1/2 integral of e to the 4 theta sine of 2 theta. Okay, so what's going to happen on this is we have this original function. So let me write the original thing out. And let's clear it up. It's 1/4 e to the 4th theta sine of 2 theta. Distribute that 1/2 out. So it becomes 1/8 e to the 4th theta cosine of 2 theta. And 1/2 times 1/2 is 1/4. The integral of e to the 4th theta sine of 2 theta d theta. Okay, so from here, we have like integrals. So we can move this one over here. So we would get 3/4 integral of e to the 4th theta sine of 2 theta d theta is equal to 1/4 e to the 4th theta sine of 2 theta plus 1/8 e to the 4th theta cosine of 2 theta. And then to get rid of the 3/4, we're going to multiply both sides by 4/3. So I completely ran out of room here, sorry. This was an actual question from an AP exam, so it's good that we are doing it. And we do it in class, and we had one on our test whenever we did this a long time ago. Do I believe it's going to show up on the 2020 free response? I sure don't. So, but it's good to review how to do that. So whenever you have an e and a sine, or e and a cosine, you're going to have to integrate it twice by parts, and then you're going to add or subtract your like integral to the other side and combine your like terms. Just an FYI, make sure you watch your signs. Okay, the next question is going to be dealing with the chart. So it says the function has a continuous second derivative. The table gives the value of f and its derivative f prime of x. It's selected values of x. What is the value of the integral from 1 to 2 of x f double prime of x? So we're going to integrate by parts. So your u is going to be x, your du is going to be dx, your v and dv. So your dv is going to be f double prime of x. And when I integrate that, I get f prime of x. So we get x f prime of x, u times v, minus the integral of v du. That. Integral of f prime of x is going to be f of x. Okay, and we're going to be going from 1 to 2. So all we're going to be doing is plugging in. So we get 2 times f prime of 2 minus f of 2, and then we're going to plug in the 1. So it's going to be 1 times f prime of 1 minus f of 1. I'm going to read from our table. F prime of 2 is 4. So 2 times 4 is 8. F of 2 is 1. F prime of 1 is 2. And f of 1 is a negative 2. So 5 minus... 7 minus 4 comes out to be 3. Okay, so that's how we do that. Okay, we got one more table question over this. So it says the table values are given for f, f prime, g, and g prime. And I want to evaluate integration by parts, pretty much, because you got something f of x times g prime of x. So this would be your u is f of x. And your v is going to be, dv is g prime of x. And we're going to integrate by parts. We're going to, I'll do it up here. So it's u times v minus the integral v du. Okay. And it says that we're going to go from 0 to 1. Now, it gives us this as 5, this portion right here. So we don't even have to worry about that. It's just 5. So we're going to plug in the 1. So f of 1 times g of 1 minus f of 0, g of 0, and I'm going to subtract out 5. So f of 1 from our table is 4, g of 1 from our table is 12. F of 0 from our table is 2, g of 0 is negative 4, so that's going to be negative 8. So it gives you 20 minus 5 comes out to be 15. Okay. This next section is going to be partial fractions. And this will be a little bit easier. Remember, partial fractions, we use partial fractions when the bottom factors. And this was on last year's free response along with improper integrals. So it's important that you know how to do this. So the factors of 10 that add to a negative 7 is negative 5 and negative 2. So your partial fraction decomposition, when you do this, is a over x minus 5 plus b over x minus 2. Remember, we cross multiplied. And distribute it out. Okay, when we collect our x terms is a plus b. And we set it equal to 0 because there's not any x terms in the numerator. And your constant terms is negative 2a minus 5b is equal to 1. Okay, we're going to use elimination. So pick a variable you want to eliminate. I eliminated probably a first. Yeah, a. So multiply the top by 2. So I get 2a plus 2b is equal to 0. Negative 2a minus 5b is equal to 1. Those cancel, so we get negative 3b is equal to 1. So b comes out to be a negative 1/3. Now, we plug back into either one of these equations right here to figure out what your a is going to be. So a is going to be positive 1/3. Okay? So it doesn't matter which factors are first. Just make sure those go with the correct ones. So what we're going to actually be integrating is the integral of 1/3 over x minus 5 minus 1/3 over x minus 2 dx. And those are going to integrate with natural logs. If you did a u sub, the derivative of x is 1, the derivative of that is 1, so you don't have to manipulate anything. So it's just 1/3 natural log absolute value of x minus 5 minus 1/3 natural log of x minus 2 plus c. And that's it. So there's going to be a lot of integration with natural logs when we do partial fractions. Okay, this one's already factored for you. So your partial fraction decomp for this is going to be a over x plus 2 plus b over x plus 1. We're going to cross multiply. Okay, we're going to collect our x terms and our y term. X terms is a plus b is equal to 2 because the coefficient of the x term is going to be 2. Your constant terms are going to be a plus 2b is equal to 0. Now we've got to get rid of one of them. I'm going to multiply the bottom one by negative 1. Okay, so we get a plus b is equal to 2. Negative a minus 2b is equal to 0. I get b is equal to a -2. Okay, now plugging into either one of these equations up here, I get a is equal to 4. So when I go to integrate this thing, I get 4 over x plus 2 minus 2 over x plus 1 dx. And these are going to be integrations with natural logs, du over u. Your u is x plus 2, x plus 1. Derivative of those are both 1, so you don't have to manipulate anything. So it's 4 natural log absolute value x plus 2 minus 2 natural log absolute value of x plus 1 plus c. And the last one for this video. Okay, x squared minus 4x plus 3. We're going to factor that x minus 3, x minus 1. Because factors of 3 that give you a -4. Your partial fraction decomp for this is going to be a over x minus 3 plus b over x minus 1. We're going to cross multiply. We're going to collect our x terms. Set equal to 3. Your constant terms is equal to 1. So negative a minus 3b is equal to 1. These are equal and opposite, so I'm going to eliminate your a. So you get negative 2b is equal to 4. So b is equal to a -2. Okay, so if b is equal to a -2, that means a would have to be equal to 5. Whoa, wait, hold up. B is equal to... I'm dumb. Okay, yeah, that's right. 3 plus 1 is 4. Okay, it's -2. So if this is a -2, I'm just making sure I did this right. So B, yeah, let me change this really quick over here. This is why I work everything twice, so in case I mess up, I catch it. -2 and 5. So just double checking this. -5 plus, yeah, that's right. Okay, so we're going to integrate 5 over x minus 3 plus -2 over x minus 1 dx. Your u's are both x minus 3 and x minus 1. Derivative of that is 1, so you don't have to do any sort of u sub really. So it's 5 natural log of x minus 3 minus 2 natural log of x minus 1 plus c. Okay, and that is how we do partial fractions, integration by parts, and your improper integrals. The next lesson we will catch up on arc length, Euler's method, and logistical growth. So it'll be a shorter video, a lot easier to deal with. Thanks, and have a good night.